I'm going to talk to you about the different parts of my brain that is used to play a game of chess. But before I get to playing, there are some basic parts of the brain I need to talk about first. First off would be the medulla oblongata, famous from The Water Boy, where Professor Colonel Sanders mentions it, and the Water Boy thinks that his mama is right. The medulla oblongata actually regulates heart rate, respiration, and blood pressure. Next up would be the cerebellum. It makes movements fluid and precise from other motor areas of the brain, and basically even helps you sit upright. Now I'd like to get into the brain stem, and first off would be pons, which connects various brain structures involved in motor control and eye movement. It helps you even smile, grin, so forth. Next up will be reticular formation. It helps concentrate in the midst of distractions. I use this very often and everything. Since I have two kids and playing chess and hearing the kids in the background, I'm definitely taking advantage of the reticular formation. Next up is the midbrain. Like the pons, it connects various brain structures involved in motor control. Then we have the thalamus. The thalamus keeps the brain aware of what the other parts are doing. It's directly connected to the cortex. Millions of neurons go through the thalamus to be able to connect everything together. Then we have the corpus callosum. It connects two brain hemispheres to communicate with each other, basically connecting your left and your right brain together so they can communicate. Now let's get to playing. The hippocampus stores and retrieves long-term memory from the cortex. So that's being used to start off my game by retrieving information from the occipital lobes, which are used to recognize and decode visual memory, like the chess pieces. From my pawns to my king to my knights, I have to understand what they are. I then use that information and take it over to my parietal lobes, which take in visual signals and associates them with memories to give meaning, taste, touch, speech, etc. To give a meaning to my pieces, so I understand what the moves are. Then we have the frontal lobes, which are planning and defending ideas, organizing, and it converts thoughts to words. The frontal lobes is definitely a main part of my brain being used to make sure that I can plan, organize a great strategy to defeat my enemy at chess. Next, we have the temporal lobes, which stores right visual and left audio memory. Now, why is this important here, and why is it being brought up in chess? Because before I even start my game, I'm thinking in my mind, visually, how am I going to start this game out? And I look at my past memories of how I've won previous chess games. And that's how I started. So now that we have all the lobes covered here, then let's go into the cortex. The cortex is basically everything that does language, imagination, planning, reasoning, and consciousness. I mean, that's what we're talking about here. And then you have the cingulate gyrus, which helps the autonomic nervous system to adjust blood pressure, heart rate, pupil size, and other psychosomatic responses, emotional reactions. Basically, when I win the game, yeah, that's the cingulate gyrus popping off. My heart's racing. Then we have the amygdala. Pardon my French here on the pronunciation, but it helps fight response, aggressive reactions, and it also helps learning. So for an example, during my chess game, the amygdala actually kind of brought up a bad point on one of my games where I made a bad move, and I got a little too aggressive with one of my pieces, and I lost my queen because I didn't pay attention. I didn't let my frontal lobes take over and really plan and organize that move. Instead, the amygdala took over. Next up, we have the hypothalamus, which controls hunger, thirst, sex, and what that has to do with chess is I got thirsty in the middle of my game. The hypothalamus basically enacted that thirst. It's connected to the mammillary bodies. The mammillary bodies is what connects it together with the fornix, and the fornix basically sends signals from the hippocampus to the hypothalamus. So it's sending these signals actually from the parietal lobes, because I wasn't just thirsty for water, but I was thirsty for my favorite pop, which is Coca-Cola. So that's when I grabbed my Coca-Cola, because my parietal lobes told me Coca-Cola is my favorite, and the hypothalamus told me I was thirsty. Then we have the reptilian brain, which is basically the basics. We talked about this, and the reptilian brain is the basics of your brain. It's as simple as it gets. Then you have the limbic brain, which controls emotions and everything like that. Then you have the neocortex, which is what makes us human. They all work together and grow like trees. And what I mean by that is, if you noticed, me playing chess, I used every part of my brain to be able to play this game. And to play this game, the more you use the parts of your brain, the more branches that are likely to grow. So being able to use every part of your brain is very important. Games like chess, even strategy games like StarCraft, and I can name off several other games, but games really do help your brain grow because you're using all parts of your brain as opposed to just taking in visual information or just doing nothing. So definitely it's good to play games.